Hello everyone, my name is Ajay and let me start today with a statement that might sound very obvious. So what we are really talking about today is that platform engineering has already won. So we're not really competing in the platform engineering space with anything, right? I mean, this is a concept that has actually been proven and it has been really recognized across the whole industry. So if you're not familiar with what platform engineering is, this is the time for you to go brush up on that. I'm not going to go talk about the fundamentals of platform engineering today, but we'll be talking about the whole idea of moving from a self-service model to a self-evolving model within platform engineering. And this is an introduction to a Maven course I'm actually offering in March of 2026. The first cohort of this Maven course was highly recognized, and that was actually enjoyed by several people. And I'm going to be giving you a general overview of what we'll be covering in that Maven course. So if you walk into any serious digital organization today, what you will find is a combination of self-service, golden paths, portals, platform teams, IDPs, and all these terms that you would hear about. But it's not about trying to convince you about whether you should build a platform, right? So if you're taking this course, you're probably somebody who's being convinced that platforms is the way to go, and you want to go build a platform. And in some cases, you've already built the platform. The question becomes like, what happens after you build that platform? What happens once that self-service stops being enough for you? So because the next phase isn't all about building your nice user interface or faster pipelines, it's all about the platforms that can learn and adapt and evolve on their own. So let's jump right in. So when you really look at the AI transformation that is happening within the platform space, there are three major shifts. So what are these shifts? The first one is going from that reactive to predictive. What does that mean really, right? So today, the platforms, what we have built, basically react to certain things. When something breaks, an alert fires, or what happens is the humans jump in, whether it's the developers or a platform engineering team or your DevOps teams, they actually jump in and fix that. But what AI allows you to do is to have that platform start reasoning before things break. So based on trends, context, and history, it starts doing things a little bit more proactively. So the next thing to think about is that new developer workflow. So the second shift is subtle but sort of profound one, right? I mean, because developers are moving away from navigating these tools towards more of those expressing that intent. Then the question becomes like, if the developers express the intent, how do you actually translate that intent to your infrastructure implementation? So instead of clicking through portals or memorizing YAML or editing some of those things, you are getting to a point where you can describe things in a more natural language way. The third one, probably the most important, is like measuring, right? I mean, so a lot of teams who actually do the first two very well fail in that third one. Because if you start not measuring things, you have to first make sure that you're measuring the right things. But it's also about having the right kind of information to go fix the kind of problems that you have. So AI success is not about what kind of models that you pick. It's not about the model accuracy here, right? It's also about almost always about whether you can get the teams to move faster and break less and spend less time thinking about the platform. So you might actually see that platform engineering is pretty much the mainstream today, right? So you can see all the statistics here, but what really means is that the data matters because it removes that debate, right? I mean, so that's the reason why I'm showing this data. So there should never be a question about hey, is platform engineering replacing DevOps, or is it replacing DevX or whatever, right? So this is not an experimental activity either. This is something that is more mainstream. So what we are finding is that dedicated teams, executive sponsorship, and DevX is sort of the first class goal that you have, which means that the bar has definitely moved over the past few years. So simply offering self-service is table stakes. That is something that everybody expects you to do when you're building a platform. So the competitive advantage comes from how intelligent your platform is, not just about whether you have a platform, whether it can actually do some of the things that's been advertised. So let's look at this idea of golden path a little bit. Golden paths were a breakthrough, right? I mean, the idea was that if you could standardize the kind of things that developers do, then a lot more developers would actually piggyback on that and they would use it in a consistent manner. And you can obviously provide some level of parachutes, some level of ways to sort of break those golden paths and go do things in a little bit more innovative manner. But what Golden Paths really provided is that idea of reduced ticket queues, right? So you had more of those standardized environments. So it sort of started eliminating a huge amount of toil. But there is an uncomfortable truth here, right? Golden Paths assume that the developer is thinking. So essentially, they are choosing a configuration, they're debugging failures, they're interpreting trade-offs. All those things are continuing to increase their cognitive load. When you start increasing the developer's cognitive load, developers are obviously smart people. They are actually going to go do things in their own way. So what can you do as part of your Golden Paths to sort of reduce that friction and sort of completely eliminate that cognitive load? And that is really the bottleneck that has actually brought about this advent of AI into the whole platform engineering space. So AI itself is in some sort of an inflection point, if you think about it, right? I mean, this is why AI isn't just another layer in the stack. It sort of presents a phase change. For the first time, for example, platforms can now observe behavior, learn from outcomes, and improve without humans redesigning the flow. Otherwise, it's always like you have to somehow instrument your platform to figure out what is actually happening. Or you might have to go in and ask the developers, like, how did you use it? What did you think about it? And that's the feedback that was actually making the platforms better over the years. Now, there is this idea of that AI can actually observe that. And once it can observe how it is being used, both the actual user behavior as well as what happens within the system, you can really start thinking about that self-evolving ways of doing things. It can let it improve itself. So what we are really looking at is not like an autonomous chaos, but sort of adaptive intelligence. And that's the transition that we have seen over the past several years. So if you look at the past 15 years or so, we have been seeing a step-by-step progression there. And this is exactly what AI has brought to the table. So in this new world, how would the Golden Paths look? So let's try and make it very concrete, right? So today, the Golden Paths give you all the defaults. Tomorrow, the AI-guided paths give you sort of recommendations. So these are not generic ones, but more of those context-aware ones. So based on the service type, your compliance needs, or your past failures, AI can sort of learn that and improve your Golden Paths so that you have something that is again standardized that can be used. So the question becomes like, what happens when something fails? So platform doesn't just say, hey, the pipeline failed, and maybe it could even suggest a fix saying that, hey, this is the way to go fix it. How about if the platform fixes itself, right? And this is where that self-service becomes that self-guidance in the whole process. Metrics, as I mentioned earlier, is super important here, right? So metrics sort of shape the behavior, so it matters a lot. So traditional DevOps metrics are mostly lagging indicators, as we know, especially the DORA 4 metrics. That's phenomenal, being used by everybody within the industry. But these are lagging indicators. But what you really need as a developer in order for you to improve your platform engineering play is to sort of improve your leading signals. So the question becomes like, how long did it take for you to understand a problem? Was this deployment, say, likely to fail before it actually failed? What if you are able to know that, right? So based on the developer behavior, based on the code, based on what is happening, within the overall ecosystem, if the system is able to predict that deployment failure, you'd be far more successful. Then the real question is like, deployment failure is one of the many things, but the question is like, are developers being slowed down because of friction? Even if nothing is broken. I mean, there might be situations like that, and developers can't get things done fast enough. They would actually go through a certain ways of learning and having that increased cognitive load. And once you keep increasing that cognitive load, you see that the developers slow down because they have more friction. So what we really want is to platforms to become that proactive partners, not just a passive infrastructure as you look at this. So let's also look at this whole idea of knowledge as a first-class capability, right? This is where you really talk about that intellectual center of that the Maven course. So what we'd be doing in that course is talking about how do you actually make sure that knowledge becomes that primary capability that you build on, kind of thing. So your LLMs are very powerful, as we know, but the problem with LLMs is that it really does not have the context that your organizations have. So when it doesn't have the right kind of context, it starts hallucinating. And hallucinating your infrastructure and hallucinating your processes is as dangerous as it can get. So what happens is that RAG sort of grounds AI in your operational reality. So for example, you run your runbooks and you know your past incidents, your internal standards, all those things can come together and provide you the right kind of context that your system needs to sort of evolve and do the kind of things that it needs to do. So this is how generic model becomes your platform expert. So context is not just an enhancement to a platform, it's sort of the difference between having the higher levels of confidence and the correctness to what you're trying to do, instead of just applying your LLM saying that, hey, let it do what it's supposed to do. So you can't go to ChatGPT or Claude and say, hey, build me a platform or solve a particular capability, build a particular capability within your platform. That isn't going to work, because that is going to be highly contextual to what is happening within your organization, and that's where the RAGs come in. And we should also look at the overall architectural revolution here, right? Because the architecture sort of explains why AI assistants disappoint. I mean, we have had AI assistants for a few years now. The reason why it hasn't caught on is mainly because of the fact that it's probably not aware of the right kind of architecture that you have. Right? And it's impossible for it to know that. And we'll sort of bridge those gaps in this course. So essentially, these are the systems that we have, AI systems that we have in the industry. They mostly answer questions, but they don't understand your systems. So what you're really trying to do is to make those tools or processes sort of understand your system, so that the platform AI retrieves that relevant context, reasons over it, and explains the outcome. So this is that difference between trying to restart a service, which I'm sure all of you have done as part of, doing any kind of software maintenance. And the difference between going from that to more of this failed because of a config drift, similar to last Tuesday's incident, because it learns from what happened last Tuesday. So that's the kind of connective tissue that we are really going to be building in this course. Let's also talk a little bit about making knowledge actionable. So I'm sure you're all familiar with MCP servers, and if you're not familiar with MCPs, this is again a great time for you to get some basic understanding of MCPs. In this course, we will actually be building MCP servers that is applicable in the platform steering context. So this is that next giant leap, right? I mean, so essentially what we are saying is that knowing is not enough. MCP sort of allows AI to safely interact with the systems under a governed ways of doing things. So it can query a state, propose changes, execute actions when approved. So this is also how AI moves from that advisor level to that assistant level, but without really bypassing all the controls. So the blueprint of a self-evolving system is something that we would actually be building in this course. This is where you would get that full picture view, right? So nothing, so note that like what you have at the bottom is nothing new, right? These are all systems that you have. You have your Kubernetes, you have your Git and CI/CD and observability, all those are systems that you have. What you have in the middle is that new intelligence layer that we've been talking about. And as you can see, this is not just your models, these are your RAG engines and your MCP servers that contextualizes your organization's requirement for that building the platform, on top of an LLM. So now RAG plus MCP turns that raw data into that actionable understanding that you really need. And at the top, this is where that experience comes together, right? So the developers and operators experience that platform differently as a collaborator going forward, as opposed to something that they have to learn and really instruct and have them do some of these kinds of things. We'll also be talking in this course about building an intelligent developer platform. I'm sure, developer portal. I'm sure a lot of you have actually heard of Backstage, and you're probably using Backstage. I'm sure you're all using a lot of different types of portals too. But what are those intelligent portals? So there are some of the portals in the industry are coming out with some of the really great features around this one. But we will be building an intelligent developer portal within this course. So what will happen is that your search-based portals assume that developers know what to look for. And then you have conversational-based portals. They assume that they know what they want to achieve, right? So, and that's that huge difference that you want to have. You want to have converse with your portal. You want to make sure that you're not just going and searching for something, but you're asking what you need. And so instead of just getting drowned in the whole documentation, as a developer, you get that tailored guidance. And sometimes you get the tailored guidance. Sometimes you might really want the system to go in and implement that for you. So this is where that DevX stops being that convenience and starts being sort of really improving that velocity. So right now it's been like, hey, we reduce that cognitive load of the developers by providing a developer portal, Backstage or whatever, that actually helps developers find the right information. That is also an assumption built into it, right? Because when you provide developer with some information, how do you know that the developers understand that clearly? Here, what we are doing is conversing with the developers in a manner in which they are talking about what they know, and the system is actually reading that and responding to it in a manner in which that is actually applying all the documentation, all the information that it has, and in some cases even executing that. So going from the reactive ops to the predictive SLOs is that ultimate holy grail here. And we'll be talking about that as part of this course. So ops today is, I would say, reactive by design, right? So AI lets us spot risk before users feel the pain. And the dynamic baselines sort of matter because systems aren't static. So predictive error budgets let the teams act early. So if you're not familiar with terms like error budgets, again, great time for you to go look it up and make sure that you familiarize yourself with that before you sign up for this course. But these error budgets let the teams act early, not heroically, right? I mean, so these are the kind of benefits that you would see when you're going from reacting to a problem to be more of the ideas of, hey, here is my service level objectives and here's how I'm actually going to make it more predictive. Another interesting thing that you would be encountering today in your workplace, and we'll be talking about this course, is the whole idea of AI-driven triage and remediation. So think of it like alert storms where are there when the human cognition sort of breaks down, right? I mean, because you have so many different alerts coming in, the volume of alerts, the type of alerts, how it is being alerted, the language that is used, that is where humans can't quite process it. So we have ended up over the years building lots of systems to process alerts, right? I mean, we have lots of very popular tools out there. I'm not going to name names, popular tools that can actually go through the alerts and figure all those things out. So what AI does is that it sort of excels in that correlation part of it, because that's the part where humans struggle. When we get so much of data, over a course of a week or a month, we have already forgotten what came through in the earlier part of the time period. So what you end up doing is that you start creating systems that can actually remember these things and start logging it in, all that kind of things. So what if we can have the system itself sort of understand and correlate these things? So if it sees patterns across signals, it can identify the likely causes, and not only identify the causes, but it can also go propose a fix. And in some cases, if you are having the right kind of agents there, it can go not only propose the fix, it can actually fix the whole system as a whole. So automation is gated by the confidence, and the sort of builds the trust instead of fear. And if I really ask a lot of the people who are actually using AI in their infrastructure and the DevOps space, the biggest fear today is that are they doing this right? Right? Even if it is a question of not implementing it, not, let's say, take the question of like identifying the likely causes and proposing fixes and not actually fixing it, there is still the fear that, hey, is this the right thing to do? Do I have to go ask my senior engineer to make sure that this is the right thing, based on their experience? So you need to actually move that the overall organization from that culture of fear to that culture of trust. And those are the kind of things that we'll be discussing in this course. So to sort of conclude, one of the things we want to talk about here is that what are those keys to success here, right? So we know that there are lots of keys to success in AI and platform engineering. If we were to sort of condense that down, I would say there are about 5 things that you should think about. One is like, most AI platform initiatives fail for predictable reasons, right? I mean, and this is something that we have already covered a lot. And they ended up choosing sort of novelty instead of the flow, right? I mean, so if this is a cool flow, I mean, cool way of doing things, so let me actually go try it out, as opposed to making like optimizing for the flow, right? They end up building bots instead of capabilities, so ultimately the idea of building a platform is to have those capabilities that can solve certain problems. That doesn't go away just because you're actually doing some of the agentic work. So you really have to continue to focus on the flow. And then you need to also have your humans in the loop to be ensuring that you need have the right kind of decisions made. You cannot remove humans, but you have to essentially augment your AI system with the right kind of humans. So as you can see, the principles given here in this slide are probably what's going to be key for you to ensure that here is my baseline, here is my grounded state, and that is where I have to really make sure that everything I do sort of falls in line with that. Once you do that, again, the question is, you have established those 5 principles saying that I'm going to do everything like that, but how do you measure? And that is where the whole idea of why are you doing it matters. So the question is like, yeah, the reason you're doing it are like, these ones, right? Or could be a few others too, but these are the key ones. Can you actually increase your feature delivery? So the velocity of the feature delivery. If you can make it faster, you're going to get a lot of support in this. Can you actually understand your problems from production or in your lower environments faster, and can you actually fix that? And if you are doing it faster, that is going to be a huge selling point. And reduction in your production defects are just as important. It's not just about, hey, I'm going to get the same amount of production defects, so I'm going to just make it faster to find it. Sure, that's good. But the idea is like, can you actually even reduce that? And ultimately, everybody is going to be looking at numbers. And one of the easiest numbers to look for is like, what is my infrastructure cost? Am I able to optimize that effectively? So the next steps is like, if you like what you heard, definitely sign up for this course on Maven. Would love to have you there. As I said, we've been getting some fantastic feedback from our first course. This would be a great opportunity for you to, as a platform engineering practitioner or a developer, to understand what actually happens when platform engineering goes into that next phase, where you can start understanding like, hey, what are the kind of things that you need to be thinking about to be able to do this right. So with that said, thank you so much, and I look forward to seeing you all there. Thank you.